Our warm-up today says to solve these equations. Do you guys remember how we learned to solve these?
Yeah. 5 and 2. X.
Yeah, that's called factoring. So we first need to factor it. Good, so the multiply add thing. Here it multiplies to -10, adds to 3. Yep, +5. -2 will work. Yeah, then you make them equal to 0. So x plus 5 equals 0. X minus 2 equals 0. When you solve this, we get -5 and +2. What are your questions on that one? Alright, now we can't use the factoring method on the second one because you can't factor it because there's a plus sign. So how would I do this? Subtract 64, good. So I get x squared equals -64. Then what? Take the square root of both sides. When you take the square root of both sides, you get x equals plus or minus the square root of -64, which is what? 8i, because there's a negative in there. Great. What are your questions on this? Alright. Here's what we're doing today. We're doing section 5.5. It's all about completing the square. So we are going to solve quadratic equations by completing the square. We just solved 2 quadratic equations using 2 different methods. We factored and we used square roots. Today we're going to learn a third method called completing the square. Next week we're going to learn another method, the quadratic formula. So you'll end up knowing a lot of ways to solve these things. Certain methods work better in certain situations. You'll see kind of when it's a good idea to use completing the square today. And then we're also going to use completing the square to write equations in vertex form. You do not need to write any of this down. This is just a little background information. So, alright, again, you don't need to write this down. Just some background information about what it means to complete the square. Completing the square is a process that allows you to write an expression in the form x squared plus bx as a square of a binomial. You'll see exactly what I mean in a second. The bottom's kind of important. The trick is to divide the b term by 2 and then square it and then add that new value to the end. It makes it factor really, really nicely. So in these examples, we are going to find the value of c that makes the expression a perfect square trinomial. Then write the expression as a square of a binomial. So here's number 1. We have x squared plus 6x plus c. I want to know what the c value should be. The way we do that is you divide this by 2. So you'd find the b. The b is the one with the x term next to it. Divide it by 2. That would give us 3. You square 3. That gives you 9. And you'll see why in a second we do that. But just remember, you take b, you divide it by 2, and then you square it. So I'm going to now think of this as x squared plus 6x plus 9. How would that factor? What are 2 numbers that multiply to 9, add to 6? 3 and 3. That's the whole point. We want to find a binomial. It's the same thing, so it's just that squared. So the problems you'll be given today, you'll have an x squared term and you'll have an x term, and then there won't be anything right here. You have to add something to make it factor like this. What are your questions on this idea so far? It'll make more sense as we kind of put it all together, but any questions on what we've done here? Number 2, x squared minus 12x plus c. So we want to find the c value that makes this factor like the one above, a binomial squared. So the way we do that, we take negative 12 and divide it by 2. That would give us negative 6. And what's negative 6 squared? 36. So you add 36 on the end. The signs don't make a huge deal here because every time you square it, it becomes positive. So if you did negative 12 divided by 2, you get negative 6. Negative 6 squared is 36. Or if you just thought of it as 12 divided by 2, 6. Either way, you end up with 36. Okay, so now I want to rewrite this, but instead of C, I'm going to put a 36. Now let's factor this. So what are two numbers that multiply to 36, add to negative 12? Negative 6 and negative 6. So this is x minus 6 squared. What are your questions on this? So number 3, the directions say find the value of C that makes the expression a perfect square trinomial. Then write it as a square of a binomial. So same exact process. We start by thinking of the B term divided by 2 squared. So what's 2 divided by 2 squared? 1. So now I'll rewrite it. Instead of a C, I'll put a 1. And then how would that factor? Very good. X plus 1 squared. All right, I don't want you guys to write this one down. This isn't technically one of your examples. You'll see the next problem. I'll say problem number 4. This is just kind of the whole process for you. So if I gave you this and I said solve it by completing the square, here's the process you would follow. So the first thing, you want to move the constant to the other side. So you want to have the x squared term and the x term on one side of your equal sign by itself. So we would start by subtracting 5. Now, this only works if you have a 1 as your coefficient in the front. So a really easy way to make this a 1 in the front is to just go through and divide everything by this number. So I'm going to divide each term by 9. And I end up right here. Any questions what I did so far? The next thing you want to do is the process we were just practicing. You're going to add half the middle term squared to both sides. So you take the middle term, negative 2, divided by 2 would be negative 1. Negative 1 squared would be 1. So I need to add 1 right here. This was written as the C on the last slide, but now there's nothing there. You add 1. If you add 1 to one side of the equation, what do you have to do to the other? Add 1. So I add 1 to both sides. The next step is to write the left side as a perfect square. That's what we were just practicing. How would I write the left side as a perfect square? How would you factor it? Yeah, multiply, add. So what multiplies to 1 and adds to negative 2? Negative 1 and negative 1. Right? That's the whole point. We want it to be a binomial squared. And then you just simplify the right side as well. So we're adding fractions here. That'd be like 9 over 9, which would be 4 over 9 when you added it. Any questions on the process so far? Kind of a weird way to solve, but you guys will get used to it as we do more and more. Now, take the square root of both sides. So when you take the square root of the left side, what do you get? Just x minus 1, right? On the right side, when you take the square root, we introduce this plus or minus. The square root of 4 is 2. The square root of 9 is 3. That's how we ended up right here. What are your questions on this? Okay? So this is where we left off, right? The next thing we want to do is solve for x. So how would I get x by itself? Add 1 to both sides. So I'd have 1 plus or minus 2/3. When you add them, you get 5/3. When you subtract them, you get 1/3. So that is the whole long process all put together. Question? Here's example 4. So it started out with the constant on the right side. That's really good. Remember, we just want the x squared and the x term on the left. We take b. What's b in this case? -1. What is -1 divided by 2? -1/2. What is -1/2 squared? Nope. It's going to be a positive. We'll square the top. What's 1 squared? Yeah. What's 2 squared? 4. So it's 1/4. So we're going to add 1/4 to both sides. Now, make sure your leading coefficient is 1. It is in this case. So we are ready to factor this side. What is this going to look like? It's always, I don't know if you guys have noticed this, it's always whatever you got when you did b divided by 2. Yeah, x minus 1/2 squared. And then on the right, we can add those. So 1 is like 4/4. So you add the top, you get 5/4. Do you guys remember the next step in the process? Square root. Take the square root of both sides. So we get x minus 1. You need a plus or minus. The square root of 5 just stays the square root of 5. The square root of 4 turns into a 2. What's my last step? Add 1/2. Good. Now, since these have common denominators, you can actually write it as 1. Just 1 plus or minus square root of 5 all over 2. So this is really helpful. I'll show you guys when this is great to use. So we originally started, if we got everything to one side for the original problem, we would have x squared minus x, and then that positive 1 would have been over there. So minus 1 equals 0. Can you factor this? I'll just ruin it for you. You cannot factor this, okay? So we're going to learn a formula next week. I'm sure you guys already know it, the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You could use that to solve this, or you could use the completing the square method. So it's just basically teaching you a couple different ways to solve these, especially when you can't factor. If you can factor, go for it. But if it's something like this that does not factor, you can either complete the square or use the formula we're going to learn next week. Any questions on this idea right now? All right. Here's number 5. Again, you can see in the directions that the coefficient of x squared is 1, so it kind of eliminates that division step you guys saw on that example. Now, this one you actually can factor, right? So you should already know in your head what we're going to get, but we're still going to practice the completing the square technique here. What's the first thing you want to do when you're completing the square? Yeah, you want to get rid of that constant, so subtract 5. Leave yourself a blank, though, because you're going to have to add something. What are we going to add here? Nine. How'd you get 9? 6 divided by 2, that's 3. Squared is 9. Good. So if you add 9 to the left, you got to add 9 to the right. So we already said it's 3 when you take b divided by 2. So I know in this factors it'll be x plus 3 squared. What do I get on the right side? 4. You can probably see right now why this is going to work out so nicely. My next step is square root. 4 is a perfect square. That's why this is going to be so nice. On the left side, we get x plus 3. On the right, we'll get plus or minus 2 because the square root of 4 is 2. How do I get x by itself? Subtract 3. So I have negative 3 plus or minus 2. Negative 3 plus 2 is negative 1. Negative 3 minus 2 is negative 5. So again, this is just another tool to use when you're solving quadratics. Any questions? How do you guys think we should start example 6? Yeah, we need to move that 4x. We're going to subtract 4x from both sides. Remember, you want your x squared, then your x, a space, equal sign, and then your constant. Negative 4 divided by 2 squared is 4. So I'm going to add 4 to both sides. On the right side now, we can go ahead and combine those. We get negative 9. What's our next step look like? Square root. Remember, we learned, not yesterday, the day before, the square root of negative 9 is plus or minus 3i. What's the final step here? Add 2. Good. So we get 2 plus or minus 3i. Can you actually go through and add the 2 and the 3i and then subtract the 2 and the 3i? No, it's kind of like the like terms idea. You cannot go any further with this one. What are your questions on this? You guys can see by looking at this slide, now we're doing it where the coefficient of the x squared term is not a 1. So this is kind of like that example we did between 3 and 4. You got to do an extra step in there. So what's the first thing you think we should do here? Add 8. Good. Or divide by 4. It doesn't really matter. You can do these two steps interchangeably. You could add the 8. You get 4x squared plus 24x equals 8. Then divide everything by 4. Or you can divide everything by 4 first and then move the 2 over. Either way, you should end up at this step. Let me know if you're not quite sure how I got there. Alright, so I see some bewildered faces. Let's just recap what we've done here. So we started by dividing every term by 4 because we want a lead coefficient of 1. The next thing we did was add the 2 because we want the x squared in the x term. We divided the x term's coefficient by 2. Then we squared it to get 9. When you add 9 to the left, you add 9 to the right. Our next step will be to factor this into a binomial squared. The hint I gave you earlier was it's always going to be the b divided by 2 is going to be your number inside the parentheses. So it's going to be x plus 3 squared. Don't forget to add the 2 and the 9 on the right. We get 11. Next step. Square root. So the squared's going to go away. We're going to get plus or minus the square root of 11. Can we do anything with the square root of 11? No. So what can I do? Subtract 3, and we want to put it in the front of that plus or minus. So negative 3 plus or minus the square root of 11. I'm pretty sure in your book, just from looking earlier, I think it always writes it out as negative 3 plus square root of 11, negative 3 minus square root of 11. I actually prefer it this way. It's easier to write and it's easier to grade, so just keep it like this. What are your questions? Here's another example. Our lead coefficient, again, is not a 1. So before we can start the completing the square process, what do we need to do? Divide everything by 3. Good. Now we're working with x squared plus 4x minus 3. That's going to be a lot easier to deal with. Next step. Yeah, first you got to add 3. Then you were right. We want to divide 4 by 2, and then we want to square it. Yeah, plus 4 and plus 4. How does the left side factor? X plus 2 squared. And on the right side, we just have a 7. Next step is to square root. Good. X plus 2 squared. Square root is just x plus 2. And then we get plus or minus the square root of 7. The final step, subtract 2. Wonderful. Here's our answer. All right, here's the next thing we're going to talk about. It's very on this one, in order to write it in vertex form, we want to get the x squared and the x term by itself. So the first thing you want to do is subtract that 2 over by the y. Now, this is just kind of written a little bit backwards from what we were doing on the last one, but it's the same completing the square process. So, what is 8 divided by 2? 4. And what is 4 squared? 16. So you add 16 to both sides. Simplify on the left, you get plus 14. On the right, we can write it like this. We just factor it into a binomial squared, so x plus 4 squared. Now, here's where it's different from the last examples we were doing on completing the square. When you're writing something in vertex form, we want x plus or minus some number in parentheses squared. So you do not want to take the square root right now. However, we want the y to be by itself. So how would you get the y by itself? Yeah, subtract the 14. This is written in vertex form. So it's using completing the square to write it in vertex form. So it's the same completing the square process, just a little different. Now we could actually graph this. I'm not going to make you graph them, but we could, right? We know the vertex is at -4, -14. A is positive, so we know it opens up. So this form is very useful for graphing. That's the whole point of going from here to here. What are your questions on this? Here's one more example of writing it in vertex form. So again, we're going to use what we know about completing the square to write this as x with a number in parentheses squared, and then the y value of the vertex on the end. So the first thing we want to do is move that 10 by subtracting. So we'll have y minus 10. Leave a space because you're going to have to add something over there. And it's going to equal our x squared minus 4x. What am I going to add to both sides? 4. Good. I took the -4 divided by 2 and I squared it. On the left we can simplify. It's just y minus 6. On the right we can factor it. What's it going to look like? Yep, x minus 2 squared. One more step to vertex form, and it is get that 6 back where it belongs. So add 6. Now, this is in vertex form. Vertex form is super handy because you can instantly find the vertex. You are not required to. The directions don't say to. But if you wanted to, what would the vertex be? Positive 2, positive 6. You don't change the sign on the last one, just the middle one. What are your questions on all this? Is it getting a little easier? Okay, it's just a long process to remember once you kind of get the groove. It's not too challenging.
The only thing is that's only thing we learned today.
Yep. Here's your homework. You will notice that I accidentally forgot to put any problems on the vertex form. So please write on your green sheets and on your homework to do problem number 73. It's the only one where you're required to get it in vertex form like the last two examples we looked at. Make sure you work on this over the weekend. Completing the square is one of those things where you have to practice. You cannot just watch me do it and learn the skill. It's not going to work that way. So make sure you do your homework. Come with questions Monday. Monday we're going to do a lesson. Tuesday you actually have the day off. Wednesday lesson. Thursday lesson. And then I believe your homework check is next Friday, but you guys can double check your green schedules on that.